The final piece of the puzzle is how do we measure similarity? In other words, how do we quantify how similar the output of two measures are? If we're looking at a measure that gives us parametric data, so normally distributed, and both sets of data have the same units, then we use something called intraclass correlation. This is common when you're doing test-retest reliability, so you have two data sets from the exact same instrument, and they're going to have the same units. If you've got parametric data, but the data sets have different units, you would use the Pearson product moment correlation. If you have ordinal data, you would use the Spearman correlation. And if you have nominal data, you would use Cohen's kappa. The one outlier to all this is internal consistency. Here, you're evaluating whether all the items in some sort of test are measuring the same concept. For example, if you've got a survey like the functional independence measure that's got multiple questions, and you want to know whether all those questions are focused on the same thing, you're either going to use Cronbach's alpha or something called split half reliability. In split half reliability, you take your instrument and split it in two. Then you use the intraclass correlation to compare the two halves. The results from each half should be similar for the same people. What Cronbach's alpha does is split the questionnaire up into every combination of two halves. Top and bottom half, odds and even questions, all those different combinations, and does the comparison over all of them. So once you've done the right test, what is similar enough for our purposes? For reliability and criterion validity, we expect correlation to be greater than 0.9. If you'll remember, a correlation can go from -1 to +1. In most cases, we're looking for our two measures to be positively correlated, so when one goes up, the other goes up. And for reliability and criterion validity, we're expecting an extremely high correlation, which is why our cutoff is 0.9. Similarly, for Cohen's kappa, we want to see a value greater than 0.9. For internal consistency, if you use Cronbach's alpha, you're looking for a value greater than 0.7. For construct validity, where we're measuring two different instruments, we have lower expectations for agreement. Acceptable construct validity is a correlation or Cohen's kappa of greater than 0.6.